Um, Hi, welcome back to the continuing lecture series in investment analysis. This is the sixth video in bond price and bond deals. Just to quickly go over what we did in our last video, it was basically finding bond price, or calculating bond price using the price command or price function in Excel. Also, we found the invoice price or dirty price. And in Finance 100, we found, what we did was we found, stated price or quoted price or clean price. But, that's mathematically, doing and building that formula into Excel and finding it, well, it's not that difficult. We can do it that way as well. Also here, in our last example, all we did was just, using Excel's price function to find the flat price. But to get to the invoice price, we still had to, mathematically find, accrued interest for the days that the bond was held in coupon period. So actually, we don't have to rely on Excel's built-in function. We can calculate it mathematically, in other words, by building the formula into Excel. But again, if we do it and that would be also, more natural in terms of, the numerical data. Why? To use Excel's built price function or yield function, all the prices must be expressed as percentage of the value. But that part is a little, awkward for me. Why? It's not a big deal. It's not a big deal. We can do it that way. But in reality, looking at that, looking at this number, and people would generally think, oops. Of course, you learned finance, so you would know that is, not $137. But a novice or a complete, a lay person, when looking at this, they would be misled to think that the bond price is 137. No, it's not. Anyway, so we're going to move on to the next example. Next example is finding, yield, right? We can use this example right away. But this is not the example. Let's see. It's not the same. The input data are not the same thing. That's fine. We'll ignore it. But you might, some of you may have wondered, while trying to scroll up, the scroll bar is being pushed down again. And you might have noticed, why does the first row start from row number 6? some of you may have noticed, or some of you are just completely mindless, never even, uh, or, never even, it never even, entered your mind. If you're very, if you're very observant, or, uh, you would have quickly noticed something. But that's fine. I mean, that's not the main point. All these uh, Excel operations have already, preoccupied you, your mind. But if you have noticed why it starts from row 6, and why suddenly from row 9 it jumps to row 17, and then from row 24 it jumps to row 30. Well, it's because I have collapsed. Oops. I have collapsed, some rows. So let me hide, unhide function or feature. If you go to hide, go to format, hide and unhide. There's hide rows, unhide rows. Of course, I've hidden some of the rows already hidden, so I'm going to have to unhide rows. Okay, if I unhide rows, I'll have to probably the entire thing. To select the entire spreadsheet, you'll have to click on this, I would call it northwest corner. This is northeast corner, right? That's wait. Oh, that's west, right? Northwest corner. And then uh, the entire whatever operation you perform, it applies to the entire expression. So I will unhide rows. Okay, there you go. It goes all the way up to. Okay, so I have row 1, starting from row 1, and what you might see here, row 3. You would notice that the numbers are different. That's fine, because I have changed those numbers. First of all, you see that A12. So originally, this is interesting. I you can change it manually, but what I did was, I just pulled steps. So that's fine. You can enter 100 here, or and then coupon rate is 8%. And then, of course, then payment will be automatically calculated. Coupon payment will be automatically calculated because coupon is always, face value times coupon rate time divided by compounding frequency, right? And then you might feel like, entering 30 manually here, but it is not manually entered. You will see that, also you might notice that I have added these two. It was probably, it was already there, I believe. And time 0 is the today. Uppercase T is the terminal time or maturity. So January of 2030. And actually, these inputs were taken from the example we are gonna do, because using yield command, right? Finding yield to maturity using yield command. But I want to do this first. Using just the rate function, okay? So I made all these changes to the first example that was hidden. So I linked the data, see, simply make it equal to B47, and it's going to reflect what's in B47, okay? And the settlement data as well. You will see what's in B48 right there, okay? So that's why time is 30 years, and you know, if you're starting from 2000, January 2000, and end in January 2030, and of course that's 30 years, right? But instead of entering 30 manually, I did it this way because this is more logical, right? You subtract T0 from uppercase T, or the terminal time, and that will actually, why do I divide it by 365 then? I have to do, because if you just subtract it, it will give you a number of days between T0 and capital T, right? That's because that's the way the calendar dates are actually recognized by the computer, right? The computer expresses the calendar dates by adding or subtracting number of days from time zero of the computer, and the time zero of the computer is what? Actually, when computer clock was 0000, right? 00 colon 00, that was actually January 1st of 1980, right? Oh, you might, wow, why January 1980? I like 1980. I was a college freshman in 1980. But you might remember, but that's when Apple computers, Macintosh came out, and Macintosh came out in 70, I believe, yeah, 77, 78, and 81 Apple went public, right? Also, Microsoft put out their first product around that time. Now, but you may remember Y2K. What was Y2K? There was a big panic. There was a big scare. I mean, you guys, some of you were born after 2000. Some of you were born probably 2001, 2002. But if you are older than 20-something and old enough to remember Y2K scare, there was even a movie about Y2K. If you're about 29, 30, then you were probably 10 years old in 2000. And then you might remember what Y2K was, or older than if you're older than like 30 now. That was when people all panicked that what if when it's a change of millennium, right? And they all feared, Well, all the computers will crash. All will stop because they will get the computer's clock one will reset to 0, right? 0000 on midnight of December 31st of 1999, and then everything will crash. The defense network will crash, and missiles will be launched, automatically. Everything will get out of control. Planes will crash, from the sky. None of this happened. None of this happened because computers clock. The origin of time for the computer's clock is January 1st of 1980. And then every calendar date is actually expressed by adding number of days to that. Well, prior to 1980, subtracting number of days. Okay, so that took a big chunk of our time. I didn't mean to do this, but to explain why we are dividing by 365. Okay, and then number of I don't need two decimals there. So actual number of compounding or actual number of coupon will be 60, which is right, which will be 2 times 30, right? Okay. So now we can find in this case, the periodic rate. You know what periodic rate is? It's the actual rate that gets compounded, which is also called, in bond, periodic rate is not automatically internal rate of return, but in the bond context, it's the internal rate of return. I'll come back with, there will be a time when I will go more, on internal rate of return later. But usually that periodic rate, the symbol for the periodic rate is R, right? Lowercase r. So let's find, our unknown is the yield to maturity, which is the annualized R. So to find rate, we can use Excel's rate function. To see what type of functions are available, you can click on this function icon. That's f of x. That means what? Function of x, right? That's the function symbol. You click on that, and usually, what you will see is, most recently used. Okay, but if you haven't used anything most recently, it's just, and you may not find the function that you want. But actually, I've used it recently, so I see rate function there. But let's see the function categories. There are financial category, date and time, math and trigonometry, statistical functions, lookup and reference test, logical information, cube compatibility. Now, but we are using basically, financial functions because we are in a finance class, and this was all done in Finance 100. So you should, if you click on financial and scroll down, it's in alphabetical order. So you will stop where you see the rate, right? Hit OK, and it's asking for the inputs. Okay, so first it's asking for n periods, and n number of periods. N is, there you go. All right, you click it in. Payment, this is the payment. You enter it. And of course, this is a financial calculator setup, right? This is a financial calculator setup. So currently everything is expressed. The dollar values are expressed as percentage of the face value, 1,000. It's gonna, but when you use rate function, you don't have to do it that way. When you use rate function, you'll see, And present value, this is the present value. But when you use, okay, and future value, this is the future value, right? And then type means, whether it is, annuity due or ordinary annuity. Now you remember from Finance 100, there are two types of annuities, ordinary annuity and annuity due. Of course, ordinary annuity is the default. An ordinary annuity is when the payment is made at the end of each period. An annuity due is when the payment is made at the beginning of each period. Now, if you buy bond, you don't receive coupon payment to begin with, right? You will receive coupon payment at the end of the first 6 months, right? Make sense? So it's ordinary annuity, right? If it is ordinary annuity, you leave blank. You enter nothing because ordinary is the default. Or you enter zero. Zero means there is no value, right? No. If it is annuity due, you enter 1. And why 1? Remember, in Finance 100, you must have learned, at least if you took Business 210 with me, you would remember that I mentioned the only difference between ordinary annuity and annuity due is one more compounding. So to find annuity due, present value of annuity due or future value of annuity due, all you need to do is just recycle the ordinary annuity result, right? You found ordinary annuity, present value of ordinary annuity, or future value of ordinary annuity. You found it, and then you just compound it one more time. In other words, multiply by 1 plus R again, and then you have annuity due. So in this case, since it is an ordinary annuity, you leave that blank or enter 0. If you enter 1 for annuity due, that 1 means one more compounding. Okay. Now here is another thing. Now let's think about it. Bond is a typical case of multiple cash flow. Combination of annuity and single cash flow model, multiple cash flow and single. So a combination of the two. I don't need to explain this again because all the coupon payments are annuities, so it's a multiple cash flow. And then face value of 1,000, the redemption value is really 1,000. It is a typical example of present value of a single cash flow, singles. But then in a financial calculator setting, right? Always, one input is negative and the other input is positive. Why? Because there is at least one cash outflow to have at least one cash inflow. Make sense? And in annuity, first you have to pay, right? To buy this bond, you have to pay the current market price of the bond, right? So there's a cash outflow, which is negative, and after that you will receive coupon payments, which is cash inflow, and finally the par value, which is cash also inflow. So you understand what goes on here. There must be something that has to be expressed as negative, and the negative one is that present value, the cash, the present value of the bond, which is the cash outflow. So I'll make this negative, okay? So put a minus sign in front of it. Then, okay, what do you get? 3%. So that's half your rate. And what is, yield to maturity? It's annual, it's annual, annualized rate of that half year rate. So you simply, multiply that by 2. 2 is 0. Don't enter 2 manually, okay? Don't just jump the gun and jump in and, manually enter 2. That's forbidden, okay? No, no, no. That's called hard coding. And hard coding is something you should that should be forbidden, because when you hard code, meaning enter unless it is initial data, you don't enter it manually. Anything that is the result of any calculation, or if the data is already input data is available in the model, you recycle that data. In other words, you have to soft code, because if you hard code any model, any formula, then it cannot be reused, it cannot be replicated, it cannot be recycled, because it is already some data value is already fixated on the previous example, where you cannot move on to the new example by copying the formula, because the data is already locked into some previous example. You understand? Okay. So you just what if m was 4? You cannot in this, if you enter 2 there automatically, if you manually put 2 there, it cannot automatically adapt to the new environment, new conditions. Okay? That's why you don't enter numbers manually. Or the only numbers you enter manually are only the initial conditions, initial input data. Okay? So that is percent. Okay? And I've been telling you, this was done deliberately, as expressed like how the bond values are expressed. Now I can suppose I change this to 1,000, and then change everything. This one has to be wait a minute. I linked it to B50, so I multiplied by 10. I think that's the correct value. Yeah, I could have done. If it was, expressed as, $1,000, it's fine. It will still work. Now, finally, let's do this. We can do this by, using yield function in this example. But to use yield function, right? To use yield function, that's really when everything has to be expressed as percentage of the par value. So let me move on to the this problem. This is not. There's nothing really. We already coupon rate is given there. So everything is expressed. Redemption value 100%, right, of $1,000. Bond price, also expressed as percentage of the par value. So here, let's use yield. Yield function comes up. Okay, I can do it this way, or using you can settlement. We'll keep doing this way because the inputs that must go in there, variables that must go in there, are already shown. But sometimes using this is more safer. right? But that's fine. Especially when you're using rate function, it's always safe to use, this function symbol, because if you just use rate function, some of the variables that must be entered uh, uh, are missing. It's not showing the full extent of the variables to go. Now, so settlement date, okay. And another thing is you have to enter comma manually. Maturity date, yes, you enter. Rate means always, the coupon rate. There you go. Price is the current price of the bond, the market price. Redemption, yes, 100. And then frequency, 2, right there. Basis, let's actual, because it's always. We'll give you 6%, right? And for why do I have this thing? Oh, if it is, if the coupon payment is I'll copy this and paste it here. If the coupon frequency is annual, how is it going to change that? A slight difference, right? You might say, one is 0.01%, so it's not a big. You may say it's not a big deal. No, if you have, if you have like, $10 billion in bond, 1% of 10 billion is what? 100 million, right? And 0.1% is, 10 million. 0.01% is still 1 million, right? And you understand why there's a difference, slight difference, because the higher the compounding frequency, right? The higher the compounding frequency, uh, uh, the greater the future value, or higher the compounding, the higher the compounding frequency. Here's a actually that should give you a slightly better yield. I mean, in annual coupon case. Well, time's up. We're gonna have to continue in the next video. So I'm gonna stop recording, and I'll see you guys in the next video.